Cool. Okay. Hello everyone, and welcome to our talk, One Click to Infiltrate Your Organization via Vulnerable VS Code Extensions. So what are we going to cover? First of all, we'll do an intro, then we'll talk about the motivation, why did we do this research? Afterwards, we will describe our processing pipeline, followed by some vulnerable extension examples with demos, and we will wrap it up with disclosures, fixes, and mitigations. But first, hello, my name is Raul. I'm a security researcher in Snyk.
Hi, my name is Kirill. I'm security team lead at Snyk.
So why did we choose Visual Studio Code? But before we can answer that, we need to ask ourselves a different question. Why even try to attack developers? So I guess we've all seen this SDLC diagram, and developers are actually starting to shift right in it. So instead of only editing code, they're also building, testing, releasing, and deploying applications, while security has done the opposite way. Instead of only doing it at the end of the development cycle, security testing is shifting left closer to when the code is written. So it is easier to find bugs and fix them, and it's less costly. So now that responsibility is slowly transferring into the hands of developers. And let's look at a couple of examples for this. So I guess you've probably heard about dependency confusion. A researcher was able to infiltrate top companies by tricking package managers to resolve private packages from other public ones with the same name. So he was able to install his own packages in the organization and execute the code. So now it turns out that there's a kind of cat and mouse situation where you need to place some security holding packages in order for your private packages to not get squatted. So developers need to be mindful of that. In addition, 2 years ago, a research was published that said that 27% of organizations were breached as a result of unpatched vulnerabilities. And as we mentioned, that responsibility lies in the hands of developers. So if you get disclosed with a vulnerability, you need to implement a fix and merge it into your code base in order for the vulnerability to be actually mitigated. And last but not least, we've seen kind of a recent event. Event Builder is a platform for hosting webinars integrated into Microsoft Teams. And it turns out that in a public bucket, which was supposed to store recordings to be shared publicly, also private data was shared, and attackers were able to get hold of that. This was as a result of a misconfiguration in the settings, yet again, something that developers are now doing more and more. So while normal people spend most of their time in the browsers and in their mobile applications and lately Netflix, developers are doing most of the time code-related stuff, writing, testing, and improving, and they're doing it inside a code editor or an IDE. So the IDE is used for editing code, building it, debugging it, and integrating with various environments that allow for building applications. So you have your version control systems like GitHub and Bitbucket, CI/CD pipelines, and various cloud hosting and deployment ecosystems. So all of these are bundled in the IDE, as well as maybe some other unrelated stuff that are more like fun, but the IDE is like the center of gravity for the work. So if you will search for the top IDEs, you will see that up there in the top 3, you will see Visual Studio Code with one of the most popular hits. So if we look at it a bit closely, we can see that it has around 14 million active users out of the world's 24 million developers, which is like pretty big numbers. It has a fairly good industry adoption with more than 4K companies using it worldwide, and it has an extension marketplace. So you might argue, yes, Visual Studio Code is not a full-blown IDE, but once you install extensions in it, you can turn it from its out-of-the-box features into this mighty environment, and you can add language support, debuggers, parsers, and all of the integrations that we've seen, and essentially turn it into a kind of a full-blown IDE. So if we focus on its extension marketplace, we see that it has the largest marketplace of all, with almost 25,000 extensions, which is around 4 times fold bigger than the follower, which is JetBrains, with almost 6,000. So that is a lot of extensions. So essentially, as an extension is an NPM project with an added Visual Studio Code extension API that allows your extension to integrate with Visual Studio Code itself. The sources are written in JavaScript and TypeScript, and you naturally define a package JSON manifest file. And everything is bundled into a zip archive, which is called a VSIX file. Another important thing to notice is that most of the extensions are open source projects. So you can see the source code hosted on GitHub and other platforms. So how secure are these? If we look at CVE list, we see that most of the vulnerabilities that are found in VS Code are code execution ones, which are pretty severe. Like 2 examples of this. One was done before we did our research. The other was published afterwards. The first one is in a GitLab extension, which allowed to clone a repository that had a malicious GitLab binary in it, and it was executed because the extension did not specify a specific path for which it ran the binary. So if we look in the clone directory, and if it finds the binary there, it can execute it. This applies only on Windows. Another example is in the Visual Studio Code remote development extension. So a call to the SSH binary, which was supposed to connect to a remote host, allowed an attacker to specify additional command line arguments and run arbitrary commands. So 9 out of 29 is pretty good, right? It's like 30-something%. But if we look at it in comparison to the size of the marketplace, that is pretty thin, right? 9 out of 25,000 extensions. We expect that there probably be more vulnerabilities there. So our goal was to discover and exploit vulnerabilities in popular extensions that could potentially compromise an entire organization. And we built a kind of a processing pipeline to help us digest this big data set. So starting from the left, we basically downloaded all of the extensions and stored them in Google Cloud Storage. So you can see here like a snippet of that, just a bunch of VSIX files. Afterwards, we extracted the sources along with the configs. And at this point, you can basically run whatever tools you want on this data set. So you can run malware detections like Yara, maybe your static analysis tools, some dynamic analysis, and you can make it concurrent and really, really fast by using a Google Cloud or any other cloud compute engine. The results were uploaded into a Google Cloud Bigtable, and we were able to run some queries on the dataset and find some interesting stuff. So to the findings. Kirill, back to you.
Okay, the first one is instant Markdown extension. It has like 100,000, more than 100,000 installs. And essentially, it is the preview for Markdown files. On the left side, you can see Visual Studio Code with installed extension. And on the right side, you can see the browser where the Markdown file is pre-rendered. But before we start to talk about vulnerability of this extension, let's have a quick recap about what is path traversal vulnerability. Basically, whenever a user can control a file name, Like in this example, you can see get parameter file name equals to gift.png. And in a lot of cases, if validation done not properly, hacker can specify // payload to get outside of the home directory of the server and eventually get any file from the server. And then in this case, you can see etc passvd file, which contains usernames and home directories, kind of classical payload for path traversal vulnerability. Let's have a look at this code snippet. It's a simple Express application. As you can see in line 5, it works in a user's Kirill server public HTML directory. And on line 7, we have the only endpoint which is eventually going to serve any file from this directory using request URL. This server is listed on port 8888. And if we, for example, open it in the browser and specify /index.html, you can see that request URL will be exactly /index.html, and the file variable at line 8 will be the full path to the index.html. So eventually we'll serve this file to user. But if we specify something like this, basically question mark slash dot slash and so on etc passvd, we're gonna have the path join will produce this path, absolute path on your notebook or computer, and eventually path resolve will resolve it to etc passvd, so far outside of the home directory. Interesting trick here, you may notice the question mark. It's because browser by default try to resolve // segments in path of the URL, and if you use the simply the // payload, browser will just throw away all the / parts, and your path will be etc passvd directly. But if you use question mark, your path actually will be just a slash, and everything what goes after the question mark will be query parameters, and browser obviously will not sanitize the query parameters anyhow. You may ask why I'm talking about path traversal vulnerability in context of Visual Studio Code extensions. Actually, because the extension inside has the preview HTTP server. So we have the Visual Studio Code, inside we have instant Markdown extension, and inside we have preview HTTP server, which is vulnerable to path traversal. Again, it is a local web server, so what? You may say you have the firewall, maybe you don't have even static IP address or even work via VPN, so no direct connection to your laptop. But actually, if like any website can make requests to your local host because of cross-site requests functionality, and you can see, like, if you open evil.com, evil.com can make get request to your localhost 8888 and eventually get some data out of it. Let's try this out. Downstairs here, you can see Google Chrome debugger console, and you can see we are on the http example.com domain. Let's try to make the fetch request to localhost, and you will see something like example.com has been blocked by course policy. So course is cross-origin resource sharing. It's kind of security policy implemented by all modern browsers, and if we not go deep into details, by default it doesn't allow one domain make any request to another domain. In this, like on this picture, you can see that domain A can do any request inside the domain A, but cannot do any request to domain B. But you can change this behavior by changing HTTP headers. So Chrome, you win, nothing to do with that, right? No. Actually, if you Google how to bypass CORS, top 10 answers from Google will be like, you need XSS on the website you want to hack. And it makes a lot of sense, right? As we figure it out, you cannot do GET request from evil.com to localhost because default CORS policy protect you from doing that. But if you have XSS vulnerability on localhost, the payload can do GET request to your localhost because it's the same origin, the same domain. And it can make GET or POST request to evil.com because evil.com can explicitly specify headers to allow that. So, sounds like a plan, right? The only question right now is how to get XSS vulnerability on this web server. And one thing allows us to do that. Basically, as you've seen in line 5, we have we are in the working directory of current user. And if you think about it, all your projects opening in Visual Studio Code will be inside your home folder. So we always work relative to home folder. And there is one folder we can put the payload. It's a downloads folder. Basically, if we can make your browser to download file, we can craft path traversal payload, which will open this file in the browser. And it's easy to do. Like this is a screenshot of Google Chrome browser, and code snippet you can see super easy. Like we create a tag, and we just set attribute href to data URL with the classical payload of script alert1 classical XSS payload. And importantly, we call set attribute download to payload HTML. And whenever we call a.click, basically browser will automatically download file. And on Mac, for example, it will be your home folder /download/payload.html. So now we know that after this action, user laptop probably have, like in most of the cases, will have the payload HTML file right in the downloads folder. And now we have all pieces of the puzzle together. Basically, hacker can trick or convince user to open evil.com. Then evil.com is using the previous code snippet trigger download of payload HTML file. Then we can open your localhost in iframe using the previous XSS payload. So now on your localhost, you have the script from payload HTML running. This script can make GET request to localhost because it's the same origin as we talked. And eventually the same XSS payload can make POST request directly to hacker and send data of your etc passwd in this case. Let's have a look at the demo. Demo is two parts. Left side is how victims see the attack, and the right side is how hackers see the attack. Let's start from the victim one. You can see again, Visual Studio Code is running on the left side, and the user types something, and it immediately renders inside the instant Markdown extension in a browser. And one more action happening here is in terminal, we put secret text into SSH/my-secret-key just to have something what hacker aims to steal. And obviously, victim should click to malicious link. It's happening here, and immediately we can see recachly picture in the browser and some obscure file name was downloaded. Basically, nothing else happened. So for the victim, it's how exploit looks like. And for the hacker, we just run PHP server on the left side just to host an exploit and listen for some logs from user. And just in a couple of seconds, we can see that user opened the file, opened the exploit using the Chrome browser, and we were able to steal my secret key, which is equal to secret in this case. So yeah, from this point, we can steal any file from the user's laptop. That's it about the instant markdown extension. Let's switch to another one. Another one is the Latex workshop extension. It has like 1.5 million downloads, a bit more than previous one. Latex itself, it's a markup language, and one of the good features of this language is ability to render markup language to PDF. And it's done almost the same way as we've seen in the previous extension. Basically, inside the Visual Studio Code, we have Latex Workshop extension, and it spawned the HTTP server to render PDF preview page. With one addition, actually, PDF preview page is able to connect back to Latex Workshop extension via WebSocket server. This is code snippet, kind of. I'm showing it the same way as I did for instant markdown. This is super simplified version of vulnerable code. You can see again Express application with one endpoint on line 6. It's just static file endpoint which serve the favicon.ico. And we have as well WebSocket connection listening on the same port as the HTTP server. And on line 12, you can see vscode.env open external. This is API of Visual Studio Code. And this socket on open actually listens for clicks inside PDF file. Let's have a look at open external API from Visual Studio Code documentation. It is able to open HTTP and HTTPS links just in a browser. It will open a new browser tab and render the HTML page. It is able to open mail client via the mail to URL schema. And also it has like VS Code for something. But what if we specify file scheme in this case? So actually, it will use, like Visual Studio Code will use default action of your laptop for files. And in case if it's binary file, it's just gonna run this binary. And like if you specify system applications calculator application, it's just gonna spawn the application. So basically we have a comment injection vulnerability here, because if we are able to connect to your WebSocket server, we can execute any binary on your laptop. And this is diagram what we're gonna do, what we want to try to achieve. Actually, if you open evil.com in Chrome browser, we need to connect your WebSocket server and execute malicious payload. Sounds like a plan again. But one problem we have on the way to exploit it is that server actually starts on random port. And in Mac, we have like 16,000 ports in this random range. So let's try to simply brute force them. And like this is really tiny JavaScript code snippet. Basically, we go through all possible random ports and open WebSocket connection. And on line 21, if we are able to, if we were successful to open the connection, we can send malicious payload on line 24. Let's try this out. Actually, it never finished, and it works for Firefox, but Chrome actually have a hidden mechanism to protect from brute forcing ports for WebSocket connections. And after 10th attempt, I believe like it will be throttling 5 seconds each attempt, each next attempt. So it will take forever. So Chrome, you did it again, you win. Nothing to do with that. No, we can leverage the fact that HTTP server is running on the same port as WebSocket server. And like instead of brute forcing WebSocket server ports, we can create 16,000 images on the page. And I believe like it's okay because most of modern websites have more images on the same page. So at line 4, like you can see the same brute force attack, we create 16,000 images at the same time. They all hosted on a different ports. And on line 4, if we were able to load one of these pictures, we know now that your localhost is running HTTP server on the specific port. And by using this fact, we can now in line 5 connect to WebSocket server, which is, as we know, on the same port as the image, and on line 9 send a malicious payload to your localhost. Let's have a look at the demo. Here again on the left side, you can see the Latex workshop extension installed and some text file with markup language here. And on the right side, we are opening malicious URL. And it takes a couple of seconds because actually in the background, we do brute force attack as we just talked. But suddenly, after a couple of seconds, you may see calculator pops up, and this is the attack. We were able to, by just opening a URL in the browser, we were able to execute binary on your laptop. That's it. Back to you, Raul.
Thank you, Kirill. So as we've seen in Instant Markdown and Latex Workshop, we found additional two plugins that were vulnerable. Open in default browser, which is just a browser previewing extension that had a similar issue as Instant Markdown. And Rainbow Fart, we had just to say it in the talk. It's just a nice extension that makes sounds while you code and help you motivate you. So it had an SSRF and a zip-slip vulnerability. So why is this a big deal and how it's related to developers? So say you're a developer using VS Code and you're installing a vulnerable extension from the marketplace. As we've seen, an attacker can exploit it, enrich some other sensitive data on your machine, such as SSH keys, environment variables, and maybe extract source code or configurations. But you're not working in vacuum. Usually, you're part of an organization with other developers, and by obtaining this, an attacker can compromise other valuable parts. So they can steal some private data, maybe drop some more persistent binaries that can do additional malicious stuff, and even issue a full-blown supply chain attack that can compromise other customers of that organization. So while vulnerable extensions aren't by themselves supply chain attacks, they have surely the potential to be used to carry out ones. So after we wrapped up our research, we started a responsible disclosure process. We sent emails to all the extension maintainers, and within 2 weeks, all of the vulnerabilities were fixed. So kudos to the maintainers and community for doing this really in a timely fashion. And let's look at one example of a fix. So Latex workshop, as Kirill said, had the command injection vulnerability. So on the left-hand side, we see the vulnerable code, which essentially allowed the user-controlled data.url to be used unsanitized in the open external API call. So on the right-hand side, we can see the fix, which was basically eliminating this functionality altogether because it wasn't really necessary. In other cases that you might need them, you just need to sanitize the user-controlled data. So how to mitigate this? Basically, extensions hygiene is pretty similar to third-party packages. So if you're a developer using these, use only maintained and popular extensions. Most of them are open source, so look at the number of stars and when they were last committed and see that they're actively maintained. In addition, if you see extensions with unfixed security issues, just don't use them. On the other side, if you're an extension maintainer, then use security best practices when developing your code. Test your code with a vulnerability scanner. And if you do get disclosed with vulnerabilities, fix them quickly enough, because as you've seen, they can affect a lot of other users. So thanks, everyone. I hope you enjoyed. Thanks, Ekoparty, for having us. Don't run away. Join us for a Q&A.
Thank you.